All right, let's talk about Docker. You've probably heard the name, but what is it really? Well, it's a technology that honestly changed everything about how we build and ship software. It might seem complicated from the outside, but at its heart, it's built on this one incredibly powerful idea. And that's what we're going to unpack today. Every great invention starts by solving a really annoying problem. And for Docker, it all comes down to this one simple sentence from its founder, Solomon Hykes. Shipping code to the server is hard. I mean, if you've ever been a developer, you feel that in your bones. This wasn't just some minor inconvenience. It was the core frustration for pretty much everyone in the industry. And this is the exact dragon that Docker was created to slay. So, to really get why Docker was such a big deal, we have to travel back in time. Back to the chaos before containers, and trust me, it had a name for a reason. They called it the Matrix from Hell. Now, here's something that might surprise you. The actual idea behind containers, it's not new at all. I mean, we're talking about technologies that go way back. You had Shroot in 1979, which was like putting a process in a little walled-off garden in the file system. Then you had FreeBSD jails in 2000, which added more walls for networking and other processes. By 2008, we even had Linux containers, or LXC, which was getting really close to the whole package. So the technology was there, but there was a huge catch. All of these tools were incredibly complicated. They were for gurus, for specialists, not for your everyday developer trying to get their job done. And this table, this is a perfect picture of that matrix from hell. It's the reason for the most infamous phrase in all of software development. But it works on my machine, right? Look at this. The Python app works on your laptop, but boom, it fails in QA because of a different library version. The Java app fails on your machine, but magically works everywhere else. The Ruby app is fine until it hits production, and then, nope, a missing dependency. It was just this endless, frustrating game of whack-a-mole, an absolute nightmare of inconsistency. Okay, so into this mess, into this chaos, steps Docker. And this is the key point. Docker's genius wasn't some brand new from-scratch technology. It was about taking all those powerful but complicated ideas and wrapping them in a revolutionary, simple user experience. That's how it changed the game. So how did they do it? It really boiled down to three brilliant abstractions. First, the immutable image. Think of it like a read-only blueprint. Once you create it, it's locked in. It can't be changed. That gives you guaranteed consistency, no matter where you run it. Then you have the layered file system. Super clever. This lets images share common files, which saves a ton of disk space and makes everything faster. And finally, the centralized registry. This was a game changer. Imagine a GitHub for binaries, a place like Docker Hub where you could just push and pull your application packages. It made sharing software ridiculously easy. And let's just double-click on that container image concept, because it is the absolute heart of the Docker world. Seriously, think of it as the ultimate shipping container for your software. It's not just your code. It's your code, the runtime, all the libraries, the environment variables, the config files, everything it needs to run is bundled up inside this one immutable read-only template. It's the whole shebang ready to go. Okay, so we've got the what and the why. Now let's pop the hood and take a look at the how. We're going to dive inside the Docker engine. The first thing you need to know is that Docker isn't just one single program you run. It's actually a client-server application. So when you're in your terminal typing Docker run or Docker build, you're using the client, the Docker CLI. But that client doesn't actually do the work. It just sends your request over to a service running in the background, a process called the Docker daemon. And that daemon, that's the powerhouse that does all the heavy lifting. So let's follow the journey of a single command, like Docker run. It's pretty cool how it works. First, you, the user, tell the client what to do. The client then shoots an API request over to the daemon, which is also called Docker ard. Think of the daemon as the manager. The manager doesn't do the grunt work itself, it delegates. It passes the task of actually managing the container's lifecycle, starting it, stopping it, to a specialized component called containerd, the supervisor. And then containerd delegates again, calling on a low-level tool called run, the executor. Run is the one that talks directly to the Linux kernel to spin up the container. Once its job is done, run exits, and containerd keeps an eye on things. And this table just nails that division of labor. You've got Docker, the manager, handling all the high-level stuff. API requests, managing your images, setting up networking. Then you've got containerd, the supervisor, whose only job is to manage the container's life. Start, stop, pause, that's it. And finally, runc, the executor, the specialist that does one thing and one thing only: create the container. And separating these roles is what makes the whole system so much more stable and flexible. It's a really smart design. So why do we even care about this fancy architecture? What's the point? Well, the point is that it enabled this incredibly simple, powerful, and repeatable workflow. A workflow that literally became the new standard for how we all handle software. And that workflow became a mantra for developers everywhere. Build, ship, run. It's that simple. You build one of those immutable images using a simple recipe called a Docker file. You ship that single image up to a central registry, and then you can run it. Or your teammate can run it. Or the QA server can run it. Or the production server can run it. Anyone, anywhere, on any machine with Docker can pull that exact same package and run it. And the best part? It's guaranteed to work the same every single time. No more, it works on my machine. Look, the impact of this build, ship, run idea cannot be overstated. It was a seismic shift. Docker didn't just give us a cool new tool. It fundamentally transformed the industry, creating a whole new ecosystem and a legacy that we're all still living in today. As Docker just took off like a rocket, something really important happened. The rest of the industry basically said, whoa, this is too important to be controlled by just one company. So they formed the Open Container Initiative, the OCI. And to their credit, Docker did something amazing. They donated core parts of their technology to this new foundation to become open standards. Remember runc, that low-level executor? That became an OCI standard. The image format? That became an OCI standard. This was huge because it prevented vendor lock-in and let the whole community build on a shared foundation. And those OCI standards are precisely why we have amazing tools like Podman today. Podman is a fantastic alternative to Docker, and it really highlights the power of open standards because it took a different approach. The big difference is in the architecture. Docker, as we saw, uses that client-server model with a daemon that typically runs as root, the most powerful user on the system. Podman, on the other hand, is daemonless. It was built with a huge focus on security, allowing you to run containers without needing those super high-level permissions. And this kind of innovation, this kind of choice, that's the real victory of the OCI. So let's wrap this up. What Docker really did was take a powerful but niche idea, containers, and make it so simple and accessible that it became the new standard. The container became the universal package for software. And that leaves us with a really big question, right? Docker created the standard for the single application. So what's next? What will be the next standard that changes how we think about the entire cloud?